Just a quick run through of limits and a general understanding of functions. So first is the word continuity. This function is piecewise and it's continuous because when we put in the borderline value x equals 0, it has the same value here as there. So it's continuous. So there's one type of discontinuity is in a piecewise function. The other type is this type of discontinuous function y equals 4 over x minus 1, where there's an asymptote. So continuous just means connected up. Second concept, which they've said in the syllabus that you won't be examined on in a formal way, but they could use the word, is differentiable. And that means this function here is not differentiable because when x equals 0, the gradient of this is 3x squared, 0, but the gradient of this is 4. So they have a different gradient. We can see it in the diagram. Now, even though we know that x equals 0 is in this part of the piecewise function, you'd still say it's not differentiable here. So differentiable has to be continuous through the point and have the same gradient. In other words, differentiable equations look smooth. Let's just run through a few limit questions. So first of all, this one. Now, you can just see straight away that this is not convergent. Convergent meaning there is a finite answer, because x squared is just going to be far bigger than x when x gets big. We could still do L'Hopital and say 4x over 1, and then you get infinity over 1. So it is called divergent, and they won't ask you to do anything with that, but you should know the word. Convergent, on the other hand, is a question like this. So the basic rule of L'Hopital is it must look like a fraction, and the first thing you should always do is ask yourself, can I simplify the fraction before using L'Hopital? Sometimes you get a very simple cancelling where there's an x on the top in every expression and there's an x on the bottom in every expression, and you cancel it. In this one, that's the difference of two squares, x minus 3 times x plus 3. So the x minus 3 cancels and you just get x plus 3. And when you put 3 into x plus 3, you get 6. Alternatively, if you didn't spot that, you could have just used L'Hopital and differentiated the top to get 2x and the bottom to get 1. So it's 2x over 1. It's no longer a problem, so you just shove in x equals 3. Okay, this one is straightforward L'Hopital. We realize that by putting infinity into the top and bottom, we get infinity over infinity, so it's L'Hopital. We differentiate, and it's a mess, but when you put infinity into the top, you get 0, and when you put it into the bottom, what do you get? What is infinity to the minus a half? Well, if you're not sure, write it out in a form you're more familiar with. So this is now putting infinity into the top, we get 0, and putting in infinity into the bottom, we get 0. So it's L'Hopital again, but remember the basic rule of, can I simplify before using L'Hopital? So can we simplify this? Well, let's rewrite it in the other form. And now we can see this is just x to the a divided by x to the b, which is x to the minus a half, which finally is 1 over root x, and we can put infinity in safely and say that is 0. So this one we put 0 in, and we clearly see it's 0 over 0. We can't simplify, so we do L'Hopital. We put 0 in, and we get 0. That's cos of 0 is 1, so that's 0 over 0. So we do L'Hopital again, 0 over 0. And we do L'Hopital again, and as soon as we see that 24, we know the question's over, because it's definitely not infinity over infinity or 0 over 0. It's done. So we can immediately now put x equals 0 in and get 8 over 24. This one is as hard as it's going to get, I think. So first of all, L'Hopital is absolutely strictly limit of f over g, and we don't have that. And when we put 0 in, we immediately have a problem not caused by 0 over 0, but caused by log of 0, which is indeterminate. And so we can't do this question unless we turn it into a L'Hopital question. So an important little trick at the very top end is you can turn multiplying into dividing anytime you like. And now we've got an indeterminate over a indeterminate. And so this is L'Hopital, and we can differentiate the top and bottom. And now I hope you'll know what to do with this mess. You put in x equals 0, you get infinity over infinity. You're tempted to do L'Hopital again, but you shouldn't, because it simplifies. In fact, it simplifies very easily. And this is obviously just 0. Lastly, one that goes beyond the hardest. I don't think this will come up, so don't watch it if you don't want to. It's not for the faint-hearted. Limit of x to the power x. So you should be thinking, right, that's got nothing to do with L'Hopital. You also can't force a fraction onto this because it's a single function. So we are in trouble. And however, when you see x to the power x, it does occasionally creep into higher level maths. There is one thing you should very strongly consider doing, which is, first of all, giving it a name. So let's find the limit of y. And once you've given something a name, there is a trick that's going to help undo this. What is it? Think to yourself. Yes, you're right. Let's take logarithms. Because logarithms undo indices. This incredibly awkward index is now just a multiplication. Now, the thing that isn't on the syllabus, but I suppose they could tell you in an exam on like the grade 7 star question, is that we can say that the limit of log y is the limit of this, and if we find the limit of log y, we will be able to find the limit of y just by reversing the logarithm. Okay, so if we can find the limit of log y, then we can find the limit of y. Now the limit of log y is this. We've just done that. We know that's 0. So therefore, if the limit of log y is 0, then the limit of y is e to the 0, which is 1. Okay, cheers.